Working on more systems of 3 equations and 3 variables, usually x, y, and z. Today we're going to see some that are a special case and just a different little twist of what's happening with those. You do not need to write down what I have on this slide. It should already be in your notes. If we have a system of 3 equations, our objective is to somehow get 2 equations that have the same 2 of those 3 variables. 2 methods we've been using. Pick one equation and isolate one of the variables, y equals or z equals or x equals, and then plug that into both of the other 2 equations. And that gives us 2 equations with the same 2 variables. So again, this is already in your notes. Let's use this method on my first example. We'll do a substitution. Now, the different twist on these is we have 3 equations. Each equation has 2 variables. No 2 of them have the same 3 variables. Usually they're printed in the book the way you see on the left. You can leave them like that if you prefer, or you can spread them out like we have here on the right. And see, the first one's missing z, the second one's missing x, the third one's missing y. Each one is missing a different one of the 3 variables. I said we want to do this one with substitution, just to review that method. So which of the 3 equations do you think would be the easiest to use for a substitution? Probably with either the nicest fractions or the least fractions, because I know you guys aren't thrilled about fraction work. Kaylee, what are you thinking? I agree. If we take the middle one and divide it by 2, we're not going to have any fractions, right? So let's do that. Let's get our middle one here. And if I divide everything by 2, I'm going to have minus y plus z is minus 3. And that would be pretty easy to get either y equals or z equals, right, Elias? I think I'm going to do z equals just because it already is a plus. And that means z would be y minus 3. Is everybody comfortable with that? Then I take that and I plug y minus 3 in for z. So let's see, I used my middle equation. So now I'm looking at my other equations. So I'm going to put z in for this z in my third equation, which means that I have minus 7x plus 8 times, my z is now y minus 3, and that needs to equal negative 15. What do I do next, Alex? Yep, we're going to distribute. So we have minus 7x plus 8y minus 24 is minus 15. And usually we have our letters on one side and our number on the other side when we're doing systems, right? So since I have a minus 24, I think I'll add 24 to both sides. So minus 7x plus 8y is how much? That's 24 minus 15. 9. So now I have an equation with just x and y. I used my middle equation to get what I was going to substitute, and I put that into the third equation. So I've used the second and third. I've got to use the first, and somehow I want to use my first and get an equation that also has x and y. Now let's look at that first equation. Anybody notice anything about that first equation? What are you noticing, Shayla? Yeah, that one already is just x and y. I don't have to do anything to it, which is good because my substitution method in the past has been isolate one letter, like I got z equals in this one, and then substitute that into both of the others. There's no place here where I can put that z. There's no place in the first one I can substitute. But it already is what I want, so I am just going to take that and put that with the equation that I just got, and then I have a system with just x and y. Does that make sense? So this is just a little twist that we have three equations. Each of them is missing one different variable in there. It just works out a little bit differently when you start to go through the same steps. So if we have 8x minus 3y is 2, and now we need to solve that system. Okay, and let's see. I think Shayla said we could do either substitution or elimination. So let's think about it. Substitution, how will that work? I'm seeing some people kind of wrinkle up their noses, scowling at me, because we've got some weird fractions in there, right? So let's do elimination. So if I get rid of the x's, I'm going to need to multiply by 8 and by 7. And if I get rid of the y's, I'm going to have to multiply by 3 and by 8. So would you rather multiply by 3 and 8 or 7 and 8? 3 and 8, because we'll probably get some smaller numbers. Okay, so that means I need to take, let's see, the top one by 3 and the bottom one by 8 to have 24 y's. Will that get one positive and one negative, or do I need to change anything? Will that give me a positive 24y and a negative 24y, so they'll cancel, okay? So let's do that. Check my work as I go along here. Minus 21x plus 24y is 27. And oh my, 64x minus 24y is 16. Are we good with that? So yes, my y's cancel. Okay, I got to do 64 minus 21. 4 minus 1 is 3, 6 minus 43x. Okay, 7 and 6 is 13. Oh, that's not going to be that bad. 43x is 43. So what's x, everybody? So x is 1. So I have one of my three values. Now I go back and look at my other equations, and I can plug into any equation that I've gotten so far. I usually try to go back to my original ones just because I know there are no mistakes in those original ones and see what I get. So since I know x is 1, I can put it in here in the first equation and then solve that, and I'll have y, right? And I can put it, there's no place to put x in my second equation, but I can put it in my third equation and solve that for z. So x was 1. So I need you guys to solve 8 times 1 minus 3y is 2. Solve that for me. And then when you finish that, I need you to solve negative 7 times 1 plus 8z is negative 15. And then we will have our solution for our system. So solve those two for me, and then you can let me know what you are coming up with. Wait till it looks like most people have stopped writing. Mateo, what'd you get for y? Anybody else? Y equals 2. Give me thumbs up, thumbs down. So I've got thumbs up. Let me make sure I can get the same thing. 8 times 1 is an 8. So I need to subtract that on both sides. And I have minus 3y is minus 6. And if I divide by negative 3, I agree y has to be 2. And who has z for us? Who's figured z out already? Riley, what you get? Thumbs up, thumbs down, negative 1. So we'd have, this is a negative 7. So if I add 7 to both sides, 8z is negative 8. So z is negative 1. Need to write it as a triple. So let's see, x. Where do I have x? It's over there. X was 1. And let me find my y. Up there was 2. And finally, my z was negative 1. So there is my answer written as a triple. Anybody with a question on that? Okay, going to do a similar kind of system where we've got 3 equations and each one is missing a different variable. This time we are going to start off with elimination. So we're going to pick 2 equations and eliminate the same variable. And then we know we've got another equation we haven't used yet, so we have to use that. Usually we've been taking that one we haven't used with one of the ones we have used, and we eliminate the same variable. Let's see what happens with these special case systems where we already have things that are each missing one of the variables. So there are my three equations, written in a condensed form on the left, spread out on the right to make it easier to see that each one is indeed missing a different variable. If I look on the right, which letter do you think will be the easiest to eliminate, Melissa? I think the z's, because they're already both minus z. So all I have to do is multiply one of them by a -1, and it really would not matter which one I do that to. If I multiply this by a negative, that becomes a positive, and this is a negative. And if I combine these last two, I have minus 2x and a plus 3y. The z's cancel, and that equals 1. I could do it with it written in the condensed form like this, but I would have to be a little bit careful. This would be negative, this would be plus, this would be minus, the z's would cancel. I need to be careful if I leave that minus 2x right above the 3y that I don't try to combine them and say that's 1x or 1y. They're written right above each other here, minus 2x and 3y, but they are not like terms. So they are still minus 2x plus 3y, the z's cancel, and that equals 1. So write it whichever way works better for you, condensed or stretched out, whichever way keeps you from making mistakes in it. So I took my last two equations, and I got something with x and y. I need a second equation that just has x and y, and I have not yet used my first equation. So look at my first equation. I need to somehow use that and have another equation that has just x and y in it. What do you see, Grazia, when you look at the first one? I haven't used it yet. Somehow I need an equation that has x and y and does not have a z in it. That first equation already is what I need. It already has no z in it. So all I have to do is to bring it down here. 3x plus 2y is 6, and now I need to solve that system. If we do substitution, will we have nice substitutions or will we have fractions? So let's do elimination. And it looks like we either need 6x's or we need 6y's, right? And I think I'll make the x's cancel out. I already have one negative and one positive there. So I don't have to worry with multiplying by anything that's negative. So I am going to take my first one and multiply it by 3. My second one and multiply it by 2. And let's see if that gives me something that will cancel nicely. Minus 6x plus 9y is 3, and 6x plus 4y is 12. Did I do that okay? All right, if you're comfortable, go ahead and work all the way to the end and find x, y, and z. I will warn you, they are not integers. And they are not exactly very nice fractions when you get to the final answers. So don't fret that you've done something wrong when you get there. And I'll let you guys get started, and then I'll see if I can kind of catch up and give you a reference point that you can look back at if you're finding yourself getting stuck on this. Anybody get 15/13ths for y? Did I really do that right? Is that what you guys got? Okay, it's messy. Now I need to look back at my system. I know y is 15/13ths. So I'm looking for places where I can put it. Just because I've marked up my left so much, I think I'll look over here at my right. I could put 15/13ths in for this y, and I could put 15/13ths in for that y, couldn't I? So I've got at least a couple of places where I can put it. And if I put it in the first one, then I can solve for x, and the second one I can solve for z. So that's what I need you guys working on. 3x plus 2 times 15/13 equals 6, and 3 times 15/13 minus z equals 10. How many of you have finished and have already found x and z? Everybody's still working a little bit. Who has all three values now? A few hands are going up. All right, help me finish, because some of you may be getting stuck with these really strange numbers. I did 3x plus 2 times my y was 6, and so that gave me 3x plus 30/13. And so I knew I needed to change 6 to, is it 78/13? Should I do that right for 6? And so then if I subtract 30/13 from both sides, how many 13ths will that leave me? That's 78/13 minus 30/13. 48/13. And then I need to multiply that by a third, right? So that I can have just x. So what's 48 divided by 3? So 16/13, is that what you guys came up with for x? Okay, then for my z, I put in 3 times 15/13 minus z is 10. So I had 45/13 minus z, and I know 10 is 130/13. So I subtracted that from both sides, added the z to both sides. What will this give me for z? What's 45 minus 130? What is it? How much? Negative 85/13. How many got that? Not very nice fractions, but we did get all the way to the answer. Now we just have to write it in order, and you have to make sure we do x first and then y. So let's see, where was my x? X was 16/13, and my y was back here, 15/13, and then z over here for the final one, negative 85/13. So that is our solution for that system of three equations. So some of them still had some messy work just like before, but what was a little bit different was when we got to the second equation with two variables. Oh, it was just the one we hadn't already used, because we had three equations and each one was missing one different variable. So any questions with those special cases of systems? Then we work on homework for the rest of the time.